Hello everybody, my name is Riya, and in this video we're going to see how different data structures are implemented using linked list. So first of all, we'll be seeing the implementation of stack using linked list and then the implementation of queue using linked list. So first of all, let us see how stack is implemented using linked list. So it is just same like the program which we had written for linked list, and since we all know that stack follows the last in first out rule, that is whatever elements which will be inserted at the last will be popped out at first. So keeping that in mind, we'll be performing the following operations, that is push, pop, and for displaying the elements which are present in the stack, we will be using this display function. So here the name of my structure is struct stack node, and inside this we have declared the data structure members data, and this next is a pointer which will be pointing to the next node, and this is the operation for push, that is we are creating a new node and we'll be inserting the data into the data field of this new node, and then temp of next will be equal to top, and we'll be equating temp, will be putting temp inside the top. It is just same like how we perform the normal insertion operation in the stack program. In that, what we used to do, we used to first of all create a new node, that is we create a new node, and then we used to put that data inside the data element, inside the data field of the new node, and then we used to equate the head, right, that is the topmost element, to the new node. Similarly here we are using, instead of head, we are using top over here. So it is just the same, we are equating top is equal to temp finally. And for pop, we see that first of all the condition is checked, if top equal to null, that is if it is so, then the message will be displayed that the stack is empty, else again we'll be creating a new node in which we'll be storing the top value, and we'll be incrementing, we'll be pointing top to the next immediate position. So what happens is the top is moving to the next position, and we'll be storing the value of top inside the temp. Now we'll be displaying the data which is present in the top using the temp new node, and finally we'll be deleting this new node. So this is how we'll be able to move the top to the next position as well as preserve a value also, and we'll be able to delete the required element. So what are we doing? Actually we are deleting the element which was inserted at the last in, we follow last in first out, right? And for displaying, first of all again the condition is checked, if top is equal to null, if it is so, then the message is displayed that the stack is empty, else we are creating a new node, and again we are equating temp is equal to node, and then we'll be traversing up to the second last element, and until we move on to the second last element, all the data which is present until then would be displayed, and each time the value is displayed, temp will be moving to the next position. Now inside the main function we see that top is initialized as null, and we are basically to make it, we have basically written a menu driven program which will be easy for the user to understand, and he or she can perform their desired operation using these cases. So let us see how this program runs. So enter the choice, suppose I enter 1, enter the data to be inserted, suppose 5, we want to continue, yes, and again push 2, y, and 1, again 6, 3. So the elements of my stack are displayed, and let me delete any element. So see, the element which is inserted at the last is deleted first. So this is the main concept of stack, right? So it is displaying also the deleted element is 6. our program has been successfully compiled and executed. Thank you. Now similarly, let us see how to write the code for implementation of queue using linked list. So it is also just similar as what we had done for linked list, and queue follows first in first out principle. So the element which will be inserted first in the queue would be deleted first. So this is the concept that we have to keep in mind while we are writing this code. So here we have declared all these functions above the structure, and we have defined a structure node, and inside that the data members are int info and node star next. This is the next pointer which will be pointing to the next node, and we are keeping two pointer variables, one is rear and another one is front. Now these two pointer variables are initialized as null inside the main. Okay, now for enqueue operation, let us see. Similar way, we are creating a new node. We'll be entering the data into the data field of the new node, and we are pointing the next of the new node as null. That means we are making the next of new node as null, and we are checking if front is equal to null. If it is so, then we are putting the value of temp inside the front, else we are making rear move to the next position. Initially front and rear both are at the same position. Once there are more number of elements in the queue, the rear is made to point to the next position, and finally the rear is made equal to the temp. Now for deleting, we see that we have created a new node, and it is checking if front is equal to null. So if it is null, it will be displayed that the queue is empty, else we will be putting the value of front inside the temporary node that we had created above, and we'll be making the front point to the next node, and we'll be displaying the element which we wanted to delete, and using this temp pointing towards info, and finally we'll be deleting the new node. Why? Because that is containing the element which we wanted to delete. Now let us see how to write the display function. In display function, we've created a new node, and we are putting the value of front inside the temp, that is the new node, and we are checking if front is equal to null. So if it is equal to null, it will be displaying that the queue is empty, else we'll be traversing up to the second last element, and we'll be displaying each and every element of the queue. And finally, each time when we do this, we'll be making temp point to the next node. Now similarly, how we did for stack, here also this is a menu driven program, and where we have initialized rear and front as null, and similarly we have made different cases, so that it will be easy for the user to understand and execute the program. Now let's see how this program runs. Now if you want to enter any data, that is enqueue operation 45 1 2 5 8. Now let us see what will it display. So it is displaying all the elements of the queue. Now since 45 we had deleted first, we had entered inside the queue first, inserted inside the queue first, so that element is supposed to be deleted first. So the data serve is 45. Okay, this is how our program runs. Thank you.